In this video, we see an application of linear regression and understand how to use lines of best fit to make predictions. So lines of best fit are known more formally as linear regression lines. You can think about the idea that when we regress, we go back to something. So in regression, the points are going back to the average values when we think about the sample averages or sample means for the x values and the y values. So statistical methods are used in forensics to identify human remains based on the measurements of bones. In the 1950s, Dr. Mildred Trotter and Dr. Golding Glaser measured skeletons of people who had died in the early 1900s. From these measurements, they developed statistical methods for predicting a person's height based on the lengths of various bones. These formulas were first used to identify the remains of U.S. soldiers who died in World War II and were buried in unmarked graves in the Pacific Zone. Modern forensic scientists have made adjustments to the formulas developed by Trotter and Glaser to account for the differences in bone length and body proportions of people living now. We will not use Trotter and Glaser's formulas in this problem, but we will use a similar process. To illustrate the type of data analysis done in forensics, let's see if we can identify a female student based on the length of her forearm. The mystery student has a forearm measurement of 10 inches, but she is alive and healthy. Height and weight measurements for 3 female college students are given in the table. Your task is to use data to determine if the mystery student could be one of these 3 students. So we have Jane Doe number 1, who's 18 years old, female gender. Her height is 5 feet 5 inches, and I have converted that entirely to inches. So since each foot is 12 inches, someone who's 5 foot 5 inches is 65 inches tall, and her weight is 128 pounds. Jane Doe number 2 is 23 years old, female gender, 5 foot 2 inches, which is the equivalent of 62 inches, and a weight of 120 pounds. And Jane Doe number 3 is 33 years of age, female gender, height 6 feet or 72 inches, and the weight is 155 pounds. First, we need data that relates forearm length to either height or weight for females. The scatter plot over here on the right side of the page is a graph of height versus forearm length for 21 female college students taking introductory statistics at Los Medanos College. So here we have the forearm in inches on the x-axis because we are using forearm to predict an output or a response variable of height, and the height is measured in inches. So it's helpful that we've converted our heights to be just in inches and not feet in inches, so that we'll be able to find where these heights would be on the scatter plot. Based on the scatter plot, what is a reasonable prediction for the height of the mystery student? Briefly explain or show how you made your prediction. So on the scatter plot, I have used an orange highlighter to highlight the range that I think corresponds with 10 inches. So if you come to an x is 10 inches and head up and look at, what's the range here of point values from our scatter plot. So my highlighting is heights between 62 and 68 inches, and I think that captures kind of the middle range of our scatter plot heights here for that part of the graph when the forearm is 10 inches. So based on the scatter plot, we predict the mystery woman is 62 inches to 68 inches in height. The variability in the data makes it difficult to determine if one of these students is a mystery student. Could any of the 3 students be eliminated as a possibility of being the mystery student? Why or why not? So I believe that we will be able to eliminate Jane Doe number 3, who's 72 inches tall. She's outside our prediction range. So since the other 2 candidates fall within that prediction range of 62 inches to 68 inches, I think we can reliably say it's probably not Jane Doe. If we look up at outputs of 72 inches, those look like they correspond to forearm lengths of 11 or 12 inches. This is a positive association from these measurements from the female students at LMC, the 21 students who contributed to this data plot. As the forearm increases, so do the heights. So we get the positive association in this scatter plot. So we say the scatter plot has a positive linear association, And the correlation is 0.68, which is pretty strong. So the way we found the correlation is putting all the data points into StatCrunch and going summary stats, correlation. You could also do it by hand, but we know from the previous examples that it would take a long time to calculate by hand, so we will rely on StatCrunch. Since it's a pretty strong correlation, 0.68, that's really close to 0.70, which is our very strong correlation range. Any correlation above 0.40 we say is considered a strong correlation. There's a strong enough association. So it makes sense to use a linear model because we have a strong correlation here to summarize the relationship between the forearm and the height measurements. The line shown here is the line that best fits the data. So we are going to use the graph of the best fit line here to predict the height of the mystery student, and we're going to show or explain how we did this. So over on the scatter plot here, I have put a yellow highlighter dot on where the forearm length of 10 inches meets the line. And this is our regression line, also known as the line of best fit, that's giving us a prediction. And notice the line passes through the middle of the data points. What the line of best fit is doing is by running calculations, we find the line that minimizes the distance from each of these points to the line in terms of their x distances and their y distances away from the line. So the mystery student has the forearm of x equals 10 inches for the forearm measurement. And so this point that I've highlighted in yellow where 10 inches meets the line of best fit predicts a height of 66 inches. So that point we would label as 10, 66. So the point 1066 is on the best fit line. So we are going to predict that the height of the mystery student is 66 inches. Now, from StatCrunch and other technology, we can get the line of best fit equation. So from StatCrunch, we get that the predicted height, or our y value or output, equals 39 plus 2.7 times the forearm length. Or we could simplify that in terms of x and y to say y equals 39 plus 2.7x. Or if you like to have the slope first, you could say y equals 2.7x plus 39. So we are going to use the equation here to predict the height of the mystery person. So we have 39 plus 2.7 times 10, where I'm putting in that forearm measurement of 10 as the input or the x value into my equation here. And so I multiply first by the order of operations. So 2.7 times 10 is 27, and then I add up 39 plus 27, and I get just what I saw in the graph when I found the point on the line, 66 inches height. So the predicted height from the line of best fit is 66 inches. So typically, it'll be up to you if you want to read the prediction off of a graph, if the graph is really clear and easy to read like this graph, or if you want to input your explanatory value or your x value into the equation to find your prediction. I call the x variable the explanatory variable because it's our input that we're using to make the prediction for the output, or the y variable. Based on the predictions you have made, which student 1, 2, or 3 do you think might be the mystery student? Why? Student 1 with a height of 65 inches, also known as 5 feet 5 inches, is the closest height to the mystery student. So we choose a student with the height closest to the line of best fit for our predicted guess of which student we think is a mystery student.